Hello, let's continue our Sudoku adventure with Humanoid Cookies by rockratzero. It's one way of saying gingerbread men. All right, so this continues our December theme week, where we're doing holiday / winter themed puzzles for 25 days, kind of Advent style. All right, so today's puzzle, let's go over the rules. We do have normal 6x6 Sudoku rules, so in each row, each column, and each 2x3 box, we are placing the digits 1 to 6 exactly once each. Also, these lines in the grid, they start at a circle, which we call the bulb, and they're thermometers. So as you move away from the bulb, the digits have to increase. So if this was, say, a 2, this could be a 4. You don't have to go in, or you don't have to go consecutive. They just have to get bigger. What we can't do is then go back down to 3 here, because if we went 4, 3, that would get smaller, and we have to get larger as we move away from the bulb. So this could be 5, and this could be 6, for example. All right, that's thermometers. Now, you can think of these as just a bunch of overlapping thermometers, or you can think of it as branching thermometers. Either way, just look at the cell that if you were to work backwards towards the bulb, you have to keep getting smaller from there, or you have to keep getting bigger as you move away from the bulb in any direction. So hopefully that's clear. We also have crop key pairs. That's these white and black dots. Digits separated by a white dot are consecutive. So if this was 2, this could be 1 or 3, ignoring the thermo. And black dots have a 1 to 2 ratio. So if this was 2, this could be 1, because 2 is double 1. Or it could be 4, because 4 is double 2. Again, ignoring the thermo. All right, not all the dots are necessarily given. That means if we had, say, 2, 4 here, there could have been a black dot there. There's not. If we had 2, 3 here, there could have been a white dot. There's not. That's perfectly fine. That can still be the solution. All right, and that's it. Those are the rules. There's a link in the description if you'd like to try the puzzle yourself, and I'm going to get started right now. This actually does feel pretty limited. My example actually doesn't work. Remember, my example was 2, 4, and then we have to be consecutive. We go 5, and then this could be 6, but then this would also have to be 6. So this has to start pretty small. We're going to be doubling. This number is going to get doubled to here. We can't double 2 to 4. We just proved that doesn't work. We definitely can't double 3 to 6. We would have no digits left for that. So we're going to have to start at 1 and double it to 2. Now from 2, we have to go to 3. Not for 2 reasons. We have to get bigger, and also the ones already used in the column. And that means these are from 4, 5, 6. And these are from 3 through 6, which I'm not going to mark at the moment. Okay, so where's the 1 in this box? Because the 1 has to be down here somewhere, but it's not a tip of a thermo. We can't get smaller than 1. So the 1 ends up in one of these 2 cells. 3 ends up down here. Maybe I should look at this one as well. Now, does 2, 4 also break here? I think it does, because if we go 2, 4, we'd have to go 5, and then these would both have to be 6, which share a column. So this is also 1, 2, 3. And then these are also from 4, 5, 6, meaning this is a 1, 2 pair. So this is 4, 5, 6. This is 1, 2, 3. We can clean this up a little bit. So let's start by doing Sudoku. Here, this has to be smaller than these two. So it has to be the 4, because it's going to be next to a 5, 6 pair. 4 is going to go with 2 up across a black dot. That's not a 2. 4, this could be with 3 or 5. 3 is quite limited. In fact, 3 doesn't work. If this was a 3, these both have to be smaller than 3, but they can't be 1, so they both have to be 2. So this has to be a 5, which makes a whole lot more sense for that. We need a 3, 6 pair here. This could easily be a 6 right here. Okay, these are just smaller than 5. Don't read that backwards. This is just bigger than 2. All right, do we want to think about this? Okay, well, it doesn't have a 3 on it. Something important for black dots in a 6x6 is there are only 3 ways to do them. There's 1, 2, there's 2, 4, and there's 3, 6. Notice there's a problem with 1, 2, which is this can't be 1 or 2, so it's not that. And there's a problem with 3, 6, because you can't put a 3 on either of them. So the only option is a 2, 4 pair, and this 2 tells us the order. That's 4, that's 2. That's a 1 and a 2. That's not 4, that's not 4. In fact, this is a 5, 6, placing the 4 in the column. And this is a 1 to finish the box. Okay, what do I want to do here? This is 3, 5, 6. It's not a 5. These are 4, 5, 6. That's still not a 5. These thermos really aren't doing anything anymore. Okay, this is a 5, 6, because this 5, 6 goes here. And then down here we need 3, 4, 5, 6. So this can't be a 3, because 3 is not consecutive with 5 or 6. So here's the thing. There's a lot of ways to see this. One is you could just go through and say this is going to be a 5-6 or a 4-5. That's the only way that's going to work. And so it always has a 5. Another way to think about that, which can help shorthand wise, is a white dot always has one even and one odd digit, because 2 consecutive digits in general, one will be even, one will be odd. And so what's the odd digit? Well, the only odd digit available on this entire white dot is a 5. So it's going to contain the 5, meaning this is 6 and 5, meaning this is 5 and 4. All right, and that gives us the 6 and 5 here. This is 1, 2, 3. That can't be 2, that can't be 1. So the 2 in this column goes here. That does not help me. This can still be 3. What am I missing? The 1, the 2, the 5. It's not like a thermo that I can use. Okay, I think I need to pencil these then. Oh, here's the problem. This can't be 3, because if this was 3, this would also be a 2, because it can't be a 1. So that's not going to work. This is 6. This is 3. That doesn't place a 6, but this is 3, 4. This is 3, 4 only. This is 1, 3, 4. Okay. Oh, down here we get the 6. This being 6 does not help resolve this. 1, 3 pair, 1, 3, 4. What's our resolution here? There must be a constraint that I'm ignoring. What is it? 2 here, 3 here, 3, 4, 2, 5. Ah, this can't be 1. There it is. 1. Sorry, this can't be 3. Yeah, it can't be 1. It has to be bigger than the 2, so it can't be 1. So that's a 3. That's a 1. That's a 3. We get the 4 and the 1. We get the 6 and the 4 and the 5. We get the 3, 5, and 6. And there we go. Inspired by Will Power's puzzle, Baking Sheet Comes to Life. And it's got a link to it. So you want to try that? Cool. Well, and right at the end, we got a 3 in the corner that was emitting snow. That's nice. Cool. Well, nice puzzle, Rockrat. Just a little bit of a misscan there when I penciled this. It was actually right at the end. There was just 2 things that I should not have penciled a 3 here. I should not have penciled a 1 here. But it is what it is. Cool. Well, let me know how you did. If you enjoyed this, why not leave a like, subscribe, and a kind comment below.